This is the continuation of the solution of numerical problem. Now we are doing 28 now. All these numerical problem 27, 28, 29, 26, they are related to the force applied on the body due to which its motion changes. Okay, now let's start. 28 number. A bus starts to move from rest and accelerate at the rate of 2 meter per second square up to 10 seconds. Then accelerates at the rate of 4 meter per second square. Calculate the distance covered by the bus in 25 seconds. Here, acceleration is different. First, it is accelerating with 2 meter per second square. Later, it is accelerating with 4 meter per second square. Acceleration is found to be increased. Now, how to calculate, how to solve this numerical problem? We have to calculate distance covered in 10 seconds first, and then later up to 25 second means remaining 15 second how much distance it covers. Then we can add both of them. Let's start. Our bus starts to move from, we can write this way, 28 number, and since it has two parts, that's why first 10 second, it will better to say first 10 second. One case is of first 10 second. What information we have? A bus starts to move from rest. It means initial velocity is equal to 0. If a body starts from rest, then its initial velocity becomes 0. And acceleration is A is equal to 2 meter per second square. Up to 10 seconds, and the distance time is also given. Time is equal to 10 seconds. Now what we are going to calculate? The distance covered in first 10 seconds. Yeah, and then later we'll talk about the second part. Now U, A, T and S is the question. Which equation contains this U, A, T, S? We have to select that equation to solve this, to find the distance. If you remember, there are five equations we are using. Among them, one of the equation is S equal to ut plus half at square. Why I selected this? Because this equation has got these four symbols u, a, t, s. Look at this, u, a, t and s. That's why using this we can get this s. S is equal to u is 0 and time is 10 and plus half remains same. Acceleration is 2 and time is 10 square. Now this is equal to 10 into 0 means 0 plus this is 2 1s are 2 1s are, it means 1 multiplied by 10 square means 10 square is 100, and this is equal to 100, and distance is measured in meter, that's why m meter. We are using SI system to solve this numerical problem. Now let's continue. What is the question in later part? Look at this later part. Then accelerate at the rate of 4 meter per second square. Calculate the distance covered by the bus in 25 seconds. It means in 10 seconds, up to 10 seconds, 2 meter per second square is acceleration, and later for 15 seconds, total 25 seconds. 15 second acceleration is 4 meter per second square. That's why this we can say last 15 seconds. Now what are the information in for this last 15 seconds? This is okay. For this last 15 seconds, what information we have? Looking at this, acceleration is given, a is given. A is equal to what? 4 meter per second square. And for this, time is also given. T equal to how much? 15 second. 15 second. Time is given 15 second. But we have to calculate distance. Distance has to be calculated. How can we calculate distance with two information only? At least we must have three informations. That's why here we have a little problem. Now what to do? We have given just the acceleration. Looking at this question, we have given just the acceleration, and what another point, what is given? The time is given, because calculate the distance covered by the bus in 25 seconds means from the beginning 25 seconds means last 15 seconds we are going to calculate what distance is covered. Now with the help of these two, third cannot be calculated. We must have third also. That's why it will be better to have another information from first case. The final velocity of first case, first 10 second, and the final velocity of this 10 second becomes the initial velocity of the 15 second. So what can we do? We can use one equation, v equal to u plus at, and we are going to calculate final velocity of this case, first case. From first 10 second, u equal to v equal to u plus at, and the u was 0 and acceleration was 2 and the time was 10. That's why this is equal to 20 meter per second. Yes, what is this final velocity of first case? That's why I can write like this: final velocity of first 10 second is initial velocity for last 15 second. Okay, so we can add one another information. U is how much? 20 meter per second. Now we have altogether three informations given, and fourth we have to calculate a, t, u, s. The same equation contains a, t, u and s. That's why we can use s is equal to ut plus half at square, and this is equal to u is 20 into time is 15 for second case, and half remains the same. Acceleration is 4 into this time is 15 square. This is equal to 15 2s are 30, 300 plus 2 1s are 2, 2 2s are 4, and this is equal to 2 into 15, 15s are 225, and this is equal to 300 plus 225 into 2 means 450, and this is equal to 750, and distance is calculated, it is in meter. First 10 second it will cover 100 meter distance, and last 15 second it covers 750 meter distance. That's why in total 25 second how much distance is covered? 850 meter. This way we can calculate.